Every year, millions of birds embark on incredible journeys, traversing continents and oceans in a phenomenon known as bird migration. These epic voyages are among the most fascinating spectacles in the natural world. But why do birds migrate? How do they navigate such vast distances with such precision? And what triggers these remarkable journeys? In this video, we'll dive into the science behind bird migration patterns. You'll discover the reasons behind their travels, the amazing navigational skills they use, and the physiological adaptations that make these journeys possible. From the Arctic tern, which travels from pole to pole, to the tiny hummingbird crossing the Gulf of Mexico, we'll explore some of the most astonishing migratory feats in the avian world. Join us as we unravel the mysteries of bird migration, revealing the secrets of these incredible travelers and the challenges they face along the way. Whether you're a bird enthusiast, a nature lover, or just curious about the wonders of the natural world, this journey into the science behind bird migration is sure to captivate and inspire you. Stay tuned to learn more about the awe-inspiring world of bird migration. Don't forget to subscribe to our channel and hit the notification bell to never miss an update. Bird migration is the regular, often seasonal, movement of birds between their breeding and wintering grounds. This incredible phenomenon is driven by the need to find more favorable living conditions and resources, such as food and nesting sites. Migration patterns vary widely among bird species, with some undertaking short, local journeys while others embark on epic, transcontinental flights. Several bird species are well known for their migratory behaviors. For instance, the Arctic tern holds the record for the longest migration, traveling from its breeding grounds in the Arctic to its wintering grounds in Antarctica, a round trip of about 25,000 miles each year. Another notable example is the bar-tailed godwit, which completes a non-stop flight of over 8,000 miles from Alaska to New Zealand. Closer to home, the ruby-throated hummingbird migrates from North America to Central America, crossing the Gulf of Mexico in a single flight. The distances covered and the destinations reached during bird migration are truly astounding. Some birds, like the blackpoll warbler, migrate thousands of miles from North America to South America, flying over the Atlantic Ocean for days without rest. Others, such as the European swallow, travel from Europe to sub-Saharan Africa to escape the cold winter months. These journeys, dictated by a combination of genetic programming and environmental cues, showcase the remarkable endurance and navigational skills of migratory birds. In ancient times, the phenomenon of bird migration was shrouded in mystery and myth. Early theories about where birds went during the winter were often imaginative and far from accurate. Aristotle, for instance, believed that some birds transformed into different species or hibernated in the mud to survive the cold months. In medieval Europe, it was commonly thought that birds such as swallows spent the winter at the bottom of ponds or under the sea. These myths persisted for centuries, reflecting humanity's fascination and puzzlement over the disappearing and reappearing of birds with the changing seasons. The scientific study of bird migration began to take shape in the 19th century, marking significant milestones in our understanding of this natural phenomenon. One of the earliest breakthroughs was made by Hans Christian Mortensen, a Danish schoolteacher, who introduced bird ringing, or banding, in 1899. This method involved attaching small, uniquely numbered rings to the legs of birds to track their movements, providing concrete evidence of migration routes and destinations. Another significant milestone was the establishment of bird observatories, such as the Heligoland Bird Observatory in Germany, which became pivotal in collecting long-term data on bird migration. Key discoveries and contributions to the field of ornithology have greatly expanded our knowledge of bird migration. In the mid-20th century, radar technology began to be used to track bird movements, revealing previously unknown aspects of migration such as altitude and speed. Studies on the Earth's magnetic field and its influence on bird navigation have uncovered that many species use magnetoreception to find their way. Additionally, advancements in satellite telemetry and geolocators have allowed scientists to track individual birds across vast distances with incredible precision. These technological advancements, combined with dedicated field research, have unraveled many of the mysteries of bird migration, showcasing the intricate and astonishing nature of these journeys. One of the primary reasons for bird migration is the seasonal changes that affect resource availability. As seasons shift, the availability of food such as insects, fruits, and nectar can dramatically increase or decrease in different regions. In temperate zones, winter months bring colder temperatures and a scarcity of food resources. To survive, many birds migrate to warmer areas where food is more abundant. Conversely, during the breeding season, these birds return to their original habitats, which, by then, have become rich in food again, providing the necessary sustenance for raising their young. Breeding and nesting requirements also play a crucial role in driving bird migration. Many bird species migrate to specific regions that offer optimal conditions for nesting and rearing their offspring. These regions often have abundant food, suitable nesting sites, and fewer predators. For example, Arctic terns migrate to the Arctic during the breeding season, where the long daylight hours provide ample time for feeding and raising chicks. Similarly, many songbirds migrate to northern forests in the spring to take advantage of the abundant insect population and secure nesting locations that support their reproductive success. Climate and environmental factors further influence bird migration patterns. Birds are highly sensitive to changes in temperature and weather conditions, which can impact their survival and reproductive success. For instance, harsh winters in the northern hemisphere force many species to move to milder climates to avoid freezing temperatures and snow-covered landscapes. Additionally, climate change and habitat destruction are increasingly affecting traditional migration routes and timings. Birds must now adapt to shifting environmental conditions, such as altered food availability and the changing onset of seasons, which can impact their migratory behavior and overall survival. Birds possess remarkable navigational skills that allow them to traverse thousands of miles with astounding accuracy, using a variety of natural cues to find their way. One key method involves the use of the sun and stars. During the day, many migratory birds rely on the position of the sun to orient themselves. They are able to compensate for the movement of the sun across the sky by using an internal clock, maintaining a consistent direction throughout their journey. At night, nocturnal migrants such as warblers and thrushes use the stars to navigate. They have an innate ability to recognize constellations and use the rotational pattern of the night sky around the North Star to determine their direction. Magnetic field navigation is another crucial tool for migratory birds. Birds are equipped with a special sense called magnetoreception, which allows them to detect the Earth's magnetic field. This capability is thought to be facilitated by magnetite, a magnetic mineral found in their beaks or brains, and specialized proteins in their eyes that react to magnetic fields. These biological compasses enable birds to maintain their course even when visual cues from the sun and stars are obscured by clouds or during overcast conditions, providing a reliable means of orientation over vast distances. Landmarks and environmental cues also play significant roles in bird navigation. Birds often use geographical features such as mountains, rivers, and coastlines to guide their way. These landmarks provide a familiar roadmap that helps them stay on track. In addition to physical landmarks, birds are attuned to environmental cues such as prevailing wind patterns, temperature gradients, and even the smell of the ocean or specific vegetation. These sensory inputs help birds adjust their routes and ensure they reach their intended destinations. Bird navigation is a complex interplay of genetic and learned behaviors. Many migratory birds inherit an instinctual knowledge of the direction and distance they need to travel, which is encoded in their genetic makeup. This innate guidance is often fine-tuned by learning and experience. Young birds may initially rely on following older, more experienced individuals in their first migratory journey, gradually honing their own skills. Over time, they build a mental map of their migratory routes, improving their accuracy and efficiency with each subsequent migration. This blend of instinct and learning ensures that migration patterns are passed down through generations, allowing birds to successfully navigate their incredible journeys year after year. Birds undergo remarkable physiological adaptations to prepare for and endure the rigors of migration, particularly in terms of energy storage and consumption. Prior to embarking on their long journeys, migratory birds enter a phase known as hyperphagia, during which they dramatically increase their food intake to build up fat reserves. These fat deposits are crucial as they provide the primary source of energy for the prolonged flights, allowing birds to sustain themselves without needing to stop frequently for food. Fat is a particularly efficient energy source, offering more than twice the energy per gram compared to carbohydrates or proteins, making it ideal for long-distance travel. Changes in body weight and muscle structure are also essential adaptations for migration. As birds accumulate fat, their body weight increases significantly, sometimes by as much as 50% or more. However, this additional weight is carefully balanced by other physiological changes. For instance, during migration, some birds reduce the size of their digestive organs to lighten their load, reallocating energy to the muscles and fat stores. Additionally, the flight muscles, especially the pectoral muscles, which are responsible for powering wing beats, undergo hypertrophy, or enlargement, to enhance strength and endurance. This increased muscle mass enables birds to sustain the intense physical effort required for long, continuous flights. Adaptations for long-distance flight extend beyond just energy storage and muscle changes. Birds have evolved a variety of anatomical and physiological traits to optimize their migratory journeys. Many species have pointed, aerodynamic wings that reduce drag and increase flight efficiency, allowing them to glide with minimal energy expenditure. The respiratory system of birds is highly efficient, featuring air sacs that enable a continuous flow of oxygen through their lungs, ensuring that their muscles receive a constant supply of oxygen during strenuous flights. Additionally, some birds are capable of utilizing favorable wind currents and thermals to conserve energy. These adaptations collectively enable birds to travel vast distances, often across inhospitable terrains such as oceans and deserts, ensuring their survival and reproductive success in different parts of the world. Environmental triggers play a crucial role in the timing of bird migration, with photoperiod, or the length of daylight, being one of the primary factors. As days lengthen in spring or shorten in autumn, birds detect these changes through their photoreceptors, which signal the onset of migration. This change in daylight triggers hormonal shifts, particularly an increase in melatonin and other hormones that regulate physiological and behavioral changes. These hormonal changes prepare birds for the energy-intensive process of migration, prompting behaviors such as increased feeding to build up fat reserves and heightened restlessness, known as migratory restlessness or Zugunra, which indicates that the bird is ready to embark on its journey. Temperature and weather patterns also significantly influence the timing and success of bird migration. Birds are highly sensitive to changes in temperature, which can indicate the arrival of favorable conditions for migration. Warmer temperatures in spring can signal the availability of food resources in breeding grounds, while cooler temperatures in autumn can prompt birds to leave as food becomes scarce. Weather patterns, such as wind direction and speed, play a crucial role as well. Favorable tailwinds can significantly reduce the energy expenditure required for long flights, while adverse weather conditions, like storms or heavy rain, can delay or alter migration routes. Birds often wait for optimal weather conditions to ensure a safer and more efficient journey. The availability of food is another critical factor that influences migration timing. Birds migrate to areas where food resources are abundant and predictable. In breeding grounds, the emergence of insects, blooming of plants, and availability of other food sources must align with the arrival of migratory birds to ensure they have enough to eat during the energy-intensive breeding season. Similarly, in wintering grounds, birds seek regions where food remains accessible despite seasonal changes. The synchrony between migration timing and food availability is vital for the survival of both adult birds and their offspring, ensuring that they can build the necessary fat reserves and find adequate nourishment throughout their migratory cycle. Bird migration is fraught with numerous challenges and dangers, with predation and human interference being significant threats. During their long journeys, migratory birds are vulnerable to predators, including birds of prey, mammals, and even other birds. Exhausted from long flights, they often have limited energy to evade attacks. Human activities exacerbate these risks. For example, illegal hunting and trapping pose direct threats to migrating birds. Additionally, birds face hazards such as collisions with man-made structures like buildings, wind turbines, and communication towers, which can result in injury or death. Light pollution from cities can disorient nocturnal migrants, leading them off course or into dangerous urban environments. Habitat loss and climate change present profound challenges to migratory birds. Deforestation, wetland drainage, and urbanization lead to the loss of critical stopover sites where birds rest and refuel during migration. The destruction of these habitats can leave birds without essential resources, jeopardizing their survival. Climate change further complicates migration patterns by altering the availability of food and suitable habitats. Shifts in temperature and weather patterns can disrupt the timing of migration, causing birds to arrive too early or too late for optimal breeding conditions. Rising sea levels and increased frequency of extreme weather events also threaten key habitats, making the migratory journey even more perilous. Physical exhaustion and navigational errors are inherent risks in the arduous process of migration. Birds undertake incredibly long flights, sometimes spanning thousands of miles without rest. This physical exertion can lead to severe exhaustion, and in some cases, birds may not survive the journey if they cannot find sufficient food and rest. Additionally, navigational errors can occur due to various factors, including magnetic anomalies, weather disruptions, or inexperience, especially among younger birds. Such errors can result in birds straying off course, leading them into inhospitable environments or away from crucial stopover sites. These challenges underscore the incredible resilience and adaptability required for successful migration, highlighting the precariousness of these remarkable journeys. Protecting migratory routes is crucial for the survival of migratory bird species. These routes, often referred to as flyways, are the paths that birds follow during their seasonal journeys. Each flyway encompasses a series of critical stopover sites where birds can rest, refuel, and seek shelter. Conservation of these habitats is essential because any disruption along the route can have devastating effects on the bird's ability to complete their migration successfully. Ensuring the integrity of these migratory corridors involves protecting wetlands, forests, and coastal areas from development and pollution. Efforts to maintain and restore these habitats help provide safe passage for birds and support their long-term survival. International treaties and agreements play a significant role in the conservation of migratory birds. Birds do not recognize political boundaries, so international cooperation is necessary to protect them throughout their entire migratory range. Agreements such as the Convention on Migratory Species, CMS, the Ramsar Convention on Wetlands, and the Migratory Bird Treaty Act, MBTA, provide frameworks for countries to collaborate on conservation efforts. These treaties facilitate coordinated actions, such as habitat protection, research initiatives, and policies to reduce threats like hunting and habitat destruction. Through these agreements, nations commit to taking specific steps to ensure the preservation of migratory bird populations across their migratory routes. Citizen science and birdwatching contribute significantly to conservation efforts. Birdwatchers and amateur ornithologists often participate in monitoring programs such as the Christmas bird count or the Global Big Day, providing valuable data on bird populations and migration patterns. This grassroots involvement helps scientists track changes in bird distributions, identify declining populations, and detect the impacts of environmental changes. Additionally, birdwatching promotes awareness and appreciation of migratory birds, encouraging public support for conservation initiatives. By engaging local communities in fostering a connection to nature, citizen science and birdwatching play a vital role in the broader effort to protect migratory birds and their habitats. Bird migration is full of astonishing feats, including record-breaking journeys that showcase the incredible endurance and navigational prowess of migratory species. One remarkable example is the Arctic tern, which holds the record for the longest migration of any bird. These elegant seabirds travel from their breeding grounds in the Arctic to their wintering grounds in Antarctica and back again, covering an astonishing round-trip distance of up to 50,000 miles annually. This epic journey takes them across oceans and continents, demonstrating their ability to navigate with remarkable precision across the globe. Some bird species exhibit unique migration patterns beyond the typical north-south movements. Altitudinal migration, for instance, involves birds moving up and down mountain slopes in response to changing seasons. In the Himalayas, species like the Himalayan rubythroat migrate vertically, moving to higher elevations in summer for breeding and descending to lower altitudes in winter to escape harsh weather conditions. This adaptation allows them to find suitable habitats and resources throughout the year, showcasing the diversity and flexibility of migratory behaviors among birds. Case studies of specific bird species further illustrate the complexities and adaptations of migration. The bar-tailed godwit is renowned for its extraordinary nonstop flight across the Pacific Ocean. During migration, some bar-tailed godwits fly continuously for over 7,000 miles from Alaska to New Zealand without resting or refueling, a journey that can take up to 9 days. This feat is made possible by their efficient use of fat reserves and favorable wind patterns. Such studies highlight how birds have evolved specialized physiological and navigational abilities to undertake these demanding migrations, pushing the limits of endurance and survival in the natural world. These fascinating facts and case studies underscore the diversity and resilience of migratory birds. From record-breaking journeys that span hemispheres to unique migration strategies adapted to specific environments, migratory birds continue to captivate scientists and enthusiasts alike with their remarkable abilities and adaptations. Studying these migrations not only deepens our understanding of avian biology but also underscores the importance of preserving habitats and mitigating threats to ensure the continued success of these extraordinary journeys. In summary, we've explored the fascinating world of bird migration and the intricate mechanisms that drive these incredible journeys. From the navigational strategies using the sun, stars, and Earth's magnetic field to the physiological adaptations for endurance, migratory birds exemplify resilience and adaptability in the face of daunting challenges. It's important to recognize the significance of protecting migratory routes and habitats, as these journeys are essential for the survival of countless bird species worldwide. By supporting conservation efforts, creating bird-friendly environments, and participating in citizen science initiatives, each of us can contribute to ensuring the continued success of migratory birds. Take a moment to observe and appreciate the marvel of bird migration, whether it's the fleeting glimpse of a flock overhead or the arrival of a familiar species in your local park. These birds connect ecosystems across continents and enrich our lives with their beauty and song. To learn more about the science behind bird migration and to stay informed about conservation efforts, subscribe to our channel, like this video, and share it with others who share your passion for the natural world. Together, we can make a difference in protecting migratory birds and preserving their incredible journeys for generations to come. Thank you for watching and joining us on this enlightening exploration.